Okay, today we're going to finish up section 4.2. We're going to talk about the domain and the period of the sine and the cosine functions. Okay? Remember, domain has to do with the input values, and those are our t, our numbers on our imaginary number line that are wrapping around that unit circle. Okay? And the range are the coordinates, the x and the y values. Now you'll notice for sine and cosine both, their domains are negative infinity to infinity. I can take the sine and cosine of any value. But the range is going to always be from -1 to +1. It's never going to be outside of those values. So no matter what t value or what theta value I'm using, when I take the sine and cosine, I'm always going to get a value somewhere from -1 up through +1. Okay? So let's move on to the next slide here. Okay. We talked before about coterminal angles, and that by adding or subtracting 2 pi to any value of t or to any theta, we just complete a second revolution or maybe a third revolution depending on how many we want to go. Okay? So if I have the sine of some value of t and I add 2 pi n, where n is just some integer, it's just some multiple of how many times I'm going to go around the circle. If I do that, then I'm always going to end up back at the same value for the sine of t. Because I'm ending up in the same location, I'm getting a coterminal angle, I'm going to have the same sine value. And when I go to cosine, the same thing will happen. If I simply keep making rotations, one full rotation around the circle, going 2 pi, going another 2 pi, I always end up back in the same spot. So I'm going to have the same value for cosine as the angle I started with. Okay? And what we call that is we call that a periodic function. Okay? A periodic function occurs when I have some real number c such that when I add that value to the function value I started with, I still end up with the same value in the end. Okay? And that value of c, the smallest value of c for which that repeats, is called the period. Okay? So the period will have to do with when I start repeating the same output values that I had in the beginning. So we can use that idea of period to evaluate the sines, cosines, tangents of other values that are not in that 0 to 2 pi range that we looked at in our table and in our unit circle. So if I wanted to evaluate 13 pi over 6, all I'm going to do is I'm going to start out there by subtracting 2 pi, because I can see that 13/6 is more than 2. So if I take 13 pi over 6 and I subtract 2 pi, then what I'm going to end up with, 2 pi would be the same as 12/6, so 13 minus 12 would give me pi over 6, which means the sine of 13 pi over 6 is the same as the value of sine of pi over 6, which from our unit circle, the sine of pi over 6 is 1/2. So we're using those ideas of coterminal angles. We're taking an angle that's not in the first rotation around the circle, and we're relating it back to an angle that is. Because as long as they're coterminal, they're going to have the same values. Okay? Second problem, cosine of 8 pi over 3. Well, 8 thirds is again bigger than 2, so I'm going to take 8 thirds pi, and I'm going to subtract 2 pi. Okay? So subtracting 2 pi would be 6 thirds, which would give me 2 pi over 3. So the cosine of 8 pi over 3 is the same as the cosine of 2 pi over 3. So we're talking about an angle that's in that family of thirds. Remember, the cosine, 2 pi over 3 would be in the second quadrant. So the cosine relates to x, so it would have to be negative. And the cosine of 2 pi over 3 is going to be negative 1/2. Problem number 3, that's 13 pi over 4. Okay? So again, I know that fourths are one of my special groups that were in my table. 13/4 is bigger than 2 again, so I'm going to subtract 2 pi and see what angle it's coterminal with that's on that first rotation. Okay? So 2 pi, putting that in terms of fourths, would be 8 fourths, so 13 minus 8 gives me 5 pi over 4. So this is the same as the tangent of 5 pi over 4. And what I need to think about now is I'm like, okay, that's the pi over 4 family. The tangents in that pi over 4 family had a value of 1 or negative 1. So I need to think about what quadrant 5 pi over 4 is in. Well, 5 pi over 4 is more than 1 pi, so that's going to be in the third quadrant. In the third quadrant, the tangent is y over x. Both y and x are negative, so the tangent of 5 pi over 4 turns out to be positive 1. Okay? And again, that's just coming right from our unit circle values, right from our chart, those values that we're supposed to be working on memorizing or being able to find quickly. Okay? So, we talked about even and odd functions earlier in the year, and those same ideas are going to apply to the trigonometric functions. Okay? Some of the functions are even and some of the functions are odd. Okay? Notice the even functions, if I take the cosine of opposite of t, then I end up with the same value as cosine of t. And the same thing is true with the secant, because the cosine and the secant are reciprocals. Okay? Those are the functions that deal with the x values. And if you think about the coordinate plane, the positive x and the negative x, okay, I can still get the same y value. The y values are still positive. So those outputs are going to be the same. The odd functions, right, notice that when I put in the opposite of t for my input, for my domain, then I get the opposite of the value that I got originally. So the sign of negative t, or the sign of opposite of t, gives me the opposite of sine t. Okay? And the same thing for tangent, cosecant, and cotangent, all of those functions that have y's in them. So if we look at the example, if sine of t is equal to 1/3, find sine of negative t. Well, because the sine is an odd function, we know that the sine of negative t, or the sine of the opposite of t, is the opposite of the sine t. And the sine of t was defined to be 1/3, so this is going to give us negative 1/3. Cosecant of negative t, cosecant again is an odd function, so that is the opposite of cosecant t. And if the sine is 1/3, the cosecant and the sine are reciprocals, so the fact that the sine of t was equal to 1/3 tells us that the cosecant of t would be 3. Which means the cosecant of opposite of t is going to be the opposite of cosecant t, which gives us negative 3. Okay, so applying those concepts of even and odd. So the cosine and the secant, the two functions that have to do with just the x-coordinate, those are our evens, where when I put in the opposite value, I'm still going to get the original value that I started with. Okay, let's move on. Evaluate with a calculator. Now, if you notice on your calculators, the only trig values you have are sine, cosine, and tangent. So if I want to evaluate a cosecant or a secant or a cotangent, I'm going to have to use that idea of being a reciprocal. Okay? Also, notice in these problems that all of these measurements are in radians. So we're going to need to make sure that our calculator is functioning in radian mode. So you're going to have to go to the mode key on your calculator up there in the top row. Okay? And the third line down, you'll notice it says radian and degree. You're going to need to make sure that radian is highlighted. Okay? So once your radian is highlighted, you can go ahead and quit and go back. And now we have to remember that the cosecant is really the reciprocal of the sine. Okay? So what we want to do is we want to find the sine of pi over 8. So I'm going to go to the calculator. I'm going to hit the sine. I'm going to hit pi divided by 8. And I'm going to hit enter. Okay? And now I need to take the reciprocal. So if you look down the first column of keys, you've got the second key, the alpha key, the math key, and then it says x negative 1. That's the reciprocal key. So if I hit x negative 1, it's going to take the reciprocal of that value that I just looked for in the calculator. So I hit x negative 1, I hit enter, and I get approximately 2.6131. Approximately 2.6131. Okay, we're going to go to 4 decimal places with these trig functions. So problem number 7, sine of 2 pi over 3. Okay, that's the sine. The sine function is one of our keys on the calculator. So I'm going to go sine 2 pi divided by 3, enter, and I get 0.8660. Okay, so the sine of 2/3 pi is approximately 0.866. Excuse me, 660. Okay, so 2.8660. Let's clean that up. So, cotangent of 1.5. Notice, no degree symbol, so we're still in radians. The cotangent is the reciprocal of the tangent. Okay, so that's 1 over the tangent of 1.5 radians. So, I'm going to go to my calculator. I'm going to put in tangent 1.5. And it shows me 14.1014 and then some other numbers behind that. But we need the reciprocal. So now we're going to go hit that reciprocal key. Hit enter again, and I have 0.0709. 0.0709 is the approximate value of cotangent 1.5 radians. Okay? Cosecant. Cosecant, again, is the reciprocal of the sine. Okay, so I'm going to find the sine of 1.3 radians. So sine 1.3, enter. Okay. I want the cosecant, so now I need to use the reciprocal, so hit the reciprocal key, enter, and I have 1.038. 1.0378. 1.0378. Okay. So again, remembering that the cosecant, the secant, and the cotangent are just reciprocals of the sine, cosine, and tangent. So that if I need to find values for those last 3 trig functions, I just find its corresponding function and take the reciprocal. Use that x to the -1 power key. That's the reciprocal key on your calculator. Okay. So that pretty much finishes up section 2. Being able to think about finding values of the sine, cosines, and tangents, those trig values that are beyond that 2 pi, that 1 revolution, by relating them back to something in that 0 to 2 pi range, and then being able to use the calculators to find sine, cosine, and tangent values, cosecant values, and so on. Okay? Remember, we're going to have to make sure that whatever our angle is in, that the mode of our calculator is set to that. So if my angle's in radians, I got to make sure my mode's in radians. If my angle's in degrees, I need to go make sure my mode is in degrees before I try evaluating those trig functions. Okay? So, tomorrow in class, we're going to look at the day 4 problems. We'll go through some of those. We'll work on those together, and we'll make sure we got everybody on the same page and make sure there's no questions about anything. All right. Thanks a lot, and we'll see you tomorrow.